Nene sana pono chain. Nigga, what? Hang that nigga. Terry says, no, don't do it. Hang that nigga. Terry says, no, don't do it. Okay, let's look
We
at
can
this.
simply say A, B equals B and A. With list comprehension, we can create a list in one line. Instead of writing a for loop and appending the items, we can create the list like so. We use brackets and then the syntax I times I for I in range 10. This will create the very same list as in the first example. You can see the
What? I times I. I times I for I in range of 10. Okay. So if you want to create a list of 1, 2, 3, 4, is I for I. So it's written that way. Okay. Simple.
values are identical, and we can even extend this example. So if we want to use a if statement in the for loop, this would add another line, and we can simply apply the if statement at the end of the list comprehension syntax, and then again we have the same result. With the ternary operator, we can create an if-else statement in one line. Instead of writing this out, we can say var equals the first value if, then the statement, else, and then the second value. We can print only the elements of a collection in one line. So if you print data here, then this also prints the list bracket.
Let's see. It's all syntax, but anyway.
But let's say we want to print only the elements. We could write a for loop and say print I and use the end argument with a space, but this also prints a space in the end. And also if you print the next statement, this is still in the same line, so we have to add another print statement after the loop. You see, this soon becomes a bit hacky. So a simpler and better way is to say print and then a star and then the list. This will unpack the elements and print only them without a space in the end. We can print how many days are left in this year, so we import datetime, add a semicolon to stay in the same line, and then print datetime date, and then the last day of the year, minus datetime date today, and then only the days. And for today, this prints 47 days are left. And now I also want to show you that we could apply this in the terminal by saying python minus c and then add this statement. And the very cool trick now is to add this as an alias to your system. So in my case, I add this alias to my terminal configuration, and then I can use the alias and it always tells me how many days are left in the year. We can reverse a list in one line by applying list slicing. So we say A equals A, and then from start to end with a -1 step. So interview question. So with this one line, you can check if a string is a palindrome. We can easily, it's actually the same. So this is a palindrome, which is a common interview question. So with this one line, you can check if a string is a palindrome. We can easily assign multiple values to variables in one line just by defining them one after each other, and they can also take different data types. Is a palindrome. We can so with this one line you can check if a string is a palindrome. We can easily assign multiple values to variables in one line just by defining them one after each other, and then we can apply the built-in map function and map all the items to an integer, and then we have to convert this to a list, and now if we print this, then we see we have an integer list. We can read to a list, and now if we print this, then we see we have an integer list. We can read all the lines of a file into a list in one line. So here we have a text file with names, and now we can say names equals line.strip for line in, and now we open the file and we open this in read mode. And now if you print this, then it prints all.
Bro, I knew all of this. What the fuck? I knew all of this. Bro, it's not that deep. It's literally not that deep. I'm gonna do this now. I need to complete this. YouTube full stack project. Yeah, Mon. I need Mon. Mon, man, man.
देखो मैं एक बात बताता हूँ, ध्यान से सुनना, ठीक है? बिना प्लान का अगर
Oh, it takes this much time? Okay. Um, full stop.
Hey everyone, welcome back to my channel. So, we are going to start a new brand series called YouTube Clone.
देखो मैं एक बात बताता हूँ, ध्यान से सुनना, ठीक है? बिना प्लान का अगर कुछ भी आप स्टार्ट करते हो ना, जैसे फॉर एग्जांपल मान लो कि आप घर
Is it- no, no, no.
घर ही बना रहे हो। देखो मैं एक बात बता
Hello friends, welcome to my
देखो मैं एक बात बताता हूँ, ध्यान से सुनना, ठीक है? ओके गाइस, सो हम और अपलोड वीडियो, ठीक है? वीडियो एक सिलेक्ट करना है, तो मैं एक को
Yeah, everyone is like an expert in JavaScript now. That's crazy. Anyway. Bro, it looks like shit. Angular Springboard, nigga, what? Is it a full stack? Yeah, it is a full stack.
A fully functional YouTube clone using modern web technologies. Our video player comes with all the essential interactions. Users can adjust volume, switch quality settings, and even toggle captions. While watching, users can like videos to show their appreciation. They can also grow their feed by subscribing to channels they enjoy. The comment section below is where the community comes alive. Users can share their thoughts by leaving comments. Okay, I'll do this. I need to take this out. I need to create a new group. Let's create a new group. Woo! Allahu Akbar. SAS. I don't know. Let's call it SAS. Brother, chosen right. Fuck.
And NumPy. This is perfect if you are at a beginner or intermediate skill level and want to get a deeper understanding how all these algorithms work. All videos also contain a little theory section before we jump to the code. I will leave timestamps for each section, and of course all the code is available on GitHub. I also created a free NumPy handbook that covers all the essential functions that you have to know in NumPy, and it contains useful code examples for all sections. So you can download this ebook for free on my website. I will leave the link in the description.
Ah, what happened? Telling you what, bro. How did you get it off? I was goofing off. It is what it is. Why is it not working? What the hell?
Welcome everybody to your all-in-one machine.
Is Bayesian statistics used in? ML frequent frequentalist ML loss. Yes or no? Yes, Bayesian is widely used in. Okay.
Machine learning from scratch video.
Okay.
This video takes all 15 parts of my ML from scratch series and combines it into one single video. In this series we are going to implement the most popular machine learning algorithms using only pure Python and NumPy. This is perfect if you are at a beginner or intermediate skill level and want to get a deeper understanding how all these algorithms work. All videos also contain a little theory section before we jump to the code. I will leave timestamps for each section, and of course all the code is available on GitHub. I also created a free NumPy handbook that covers all the essential functions that you have to know in NumPy, and it contains useful code examples for all sections. So you can download this ebook for free on my website. I will leave the link in the description. So let's get started, and if you enjoy this content, be sure to leave me a like and consider subscribing to the channel. Hi everybody, welcome
Random K in random.
to a new tutorial. This is the first video of a new series called Machine Learning from Scratch. In this series we are going to implement popular machine learning algorithms using only built-in Python modules and NumPy. So today we will start.
No, what am I doing? Bro, now I really wish I had like a bigger computer. Fuck. Okay, maybe I'll bring in my second computer because I need to go back and forth.
Over algorithms continue. In this series the
K nearest neighbor. So we have like clusters of like things. That's what it is. ML. New file knn.py. Okay. What the fuck is that? Why can't I just copy? Can I copy all of you? Linnell, I don't know. Okay, I need another monitor. I can do this with one. If I could, I would. But I literally can't. I literally can't. Okay, cool, fine. I might need the charger. I don't need it. Go in. What do? I put this one here. For fuck's sake, man. Identify.
Hi everybody, welcome to a new tutorial.
Nigga. Okay.
K-nearest neighbor algorithm, or short KNN algorithm. The concept of KNN is fairly easy. A sample is classified by a popularity
I'll go share.
vote of its nearest neighbors. So let's consider an example with two classes and a two-dimensional feature vector. So let's have a look at this figure. So here we have two classes, the blue class and the orange class. And we have feature vectors with two dimensions. So we have x1 on this axis and x2 on this axis. And what we do here is we have some training samples, and then for each new sample that we want to classify, we calculate the distance of this sample to each of the training samples, and then we have a look at the nearest neighbors. So in this case we have a look at the three nearest neighbors, so these ones. And then we choose or predict the label based on the most common class labels here. So we have two blue classes and one orange class. So this then will be a blue class. And this is the whole concept of the KNN. And what we also have to know is, in order to calculate the distances, we use the Euclidean distance. So
yeah, Euclidean, we've seen this. So Euclidean, this is how it goes. So we have x is equal to, x is equal to some, let's say 67. I'm so funny. And y is equal to, okay, x1, y1. Okay, we have x1, y1. So this will be in some point, both of them. And x2 is equal to, oh, the fuck? x2, this will be 68. y2 is going to be, okay. And the Euclidean distance formula is d is equal to square root. How do I do square root? Um, Excuse me. Square root. Do I need Claude? Probably. Square root of how do I do it? Like, yeah, I need to import math. Okay. Math dot square root of square root of x1 minus x2 square 2 plus y1 plus y2 So the Euclidean distance would be this. So let's try print t. That will be the distance between these 2 points, which makes sense. So let's have like a smaller number. So 1, 1, negative. This should be logically like 2, I think. Yeah, 2 point something. Yeah, that makes sense. Because if you think about it, it's just, where's my pen tool? Always like my pen tool. Pen tool is how I used to express myself in some way, I think. Okay. Ah! Shit. Like shooting yourself in the foot. Okay, let's go.
In a 2D example, the Euclidean distance of 2 points is defined as the square root over, and then we have for each feature vector component.
So we're checking, so let's say we're given a point and we're checking if that point is closer to all of these points, which is, so we need to like get some sort of arbitrary like
We have
like
the squared
thing.
difference, so we have x2 minus x1 squared plus y2 minus y1 squared. So this is the Euclidean distance in a 2D case, and in a more general case, the formula is defined as this. So it's the square root over the sum from I equals 0.
Okay, it's the sum of minus 2 over the distance, 2 over the distance. Okay, that's a good formula to have. Should I write it down? So k and n, that'll be the first one. So how do we find k and n? is by this formula.
Zero to n, where n is the number of dimensions, and then we have the sum over each component, and for each component we calculate the squared
It's just a distance formula. It's the same as this thing. Okay.
distance, or the squared difference. So this is the Euclidean distance, and this is all we have to know in order to implement the k
This should be the sum of 1 is equal to 0
in n.
to n.
So let's start. And first let's define a class called KNN. And this has, of course, an init method. So init self, and this will get a k. So this is the number of nearest.
Again, k will be the numbers of nearest, which we don't know. So let's get rid of this and go class KNN. So let's try to predict what's going to come next. Self. I think it's gonna. We're gonna pass in a list of the clusters.
First, we want to consider
neighbors will be n. And nearest neighbors will be nn, maybe. I don't know. Let's see.
and this will also get a default value, so the default is 3. And in the init, we define the init. So in the init, we simply want to store the k, so we say self.k equals k. And then what we want to implement here, and here we want to follow the conventions of other machine learning libraries, for example, the scikit-learn library. So we have a fit map.
So k, okay, we were finding 3 nearest neighbor. Okay, I think I can do this. Okay. So we're finding 3 nearest neighbors of k and passing on self dot k equal to k. So we're trying to, I think we need to like pass on another thing. What are we doing? So let's say they're given a graph or whatever. So def graph k comma k comma summary. Fuck you. I'm so cringe. Why? It's fucking annoying. God damn them. Def I mean, that's what I was doing. Should I go self? So it's going to be a bunch of array given, and I need to find the Euclidean distance. I regret deleting my Euclidean distance formula. So it's going to be def d. Should I also give a self dot d is equal to how do I parse the numbers in an intelligent fashion? I think it's going to be k. No, it's going to be k is going to be. It's not going to be a number. K is nearest parameter, so it's got to be self dot val. It's going to be x1 comma x2. I mean y1. Okay, that's going to be the value. Or it could just be 1 1 for this example. Doesn't matter. And how do I represent this formula in Python? Right. What the fuck is going on? Bro, this is the best feature. What the fuck? It wasn't helpful because I'm supposed to just take this picture. But anyway. Formula for distance. Okay, I need to import np dots of x1, x2. What the fuck? What is x1 though? It's the distance. Okay. It's the value. Let's take this as x1. It's the distance one. And what? You are mental retard. Nah, it's gonna be np dot square root I think math dot square root sum of x1 minus x2. What is x2? x2 x2 is the given value. I mean, x2 is the self-proclaimed value multiplied so I can take this, cut this, do this maybe. I think that'll do it. So yeah, I think okay, what am I doing wrong? No, I don't need to zip all this shit. So x1, bro, x1 is right here. What do you mean you can find it? Okay, I'll do it here. I need to return this, okay. What is x2? Array? What the fuck is array? I thought array is going to be the a cluster. I should name it cluster, probably. It's going to be shit like that, you know. You're going to have a couple of clusters here, a couple of clusters there, and we're basically, so the x1 will be the random. How can I do random? Okay, it's not x2, it's actually something in the cluster, of course. Something in the so for k will be the nearest, okay. So k is equal to k, okay. Okay, k is equal to that. So I need to find all the possible. So for, okay, that's what I need to do. For I in clusters, I in range of 0, k. Right. I need to iterate over all of this shit. So 3 times. I need to find the nearest. How do I find the nearest in the cluster? How do I find the nearest in the cluster? I think the way I find the nearest in the cluster would be how do I do it? let's see. Here are some hints. Distant method, we are calculating values, not doing anything. The result. You can subtract these static. Think carefully about x2. Should go. You should square after summing. Oh wait, what? Cluster versus self-dot. You define self-dot cluster in it, but the method takes clusters as a parameter. This is an intent that is intentional, or should method another variable. Method signature. Does distance need k as a parameter, given that you already store? Oh, do I know? Yeah, I don't actually need none of this. Is this right? Good progress. Think about the Euclidean distance formula. You need to square each difference first, then sum. So I need to how do I do that? So okay, I need to so I need to do a square root. Okay, wait, what? Okay, let me try this. So I need a list. Do I need a list? I just need bro, just give me the full code. I don't know. Like, I'm still not looking at it, which is good. So apparently this is better somehow. Zip, I ain't zipping, nigga. The fuck. What is x1 and x2? I don't know. I don't know what is x1 and x2. Fuck you talking. All these ugly ass bitches, bro. Okay, what is cluster? Anyway, so this is the so predicting the number 3. Okay.
Square difference. So this is the Euclidean distance.
Can this shit not happen? I think yeah, I don't need this anyway. I can go get away from. That's Euclidean distance. Interesting.
And this is all we have to know in order to implement the k and n. So let's start. Consider and of the scikit-learn library. So we have a fit method. So this will fit the training samples and some training labels, and this will usually involve the training step. So we want to implement this one, and then we also want to implement a predict method. Sorry, this also has self. And the predict method, so here we want to predict new samples.
Okay, well, X and okay, that makes sense.
So these are the methods we want to implement. And now
Fucking bitch ass.
Now, before we go on, first of all, let's have a look at how our data looks. So what is this X and this Y? And for this, I wrote some test script. So here I use the famous iris dataset. So you might have heard about this already. So I can get this from the scikit-learn module. And then I will generate some training samples and some test samples.
What the fuck is that? How can I get it? Shook Canon mean Canon test Canon py. What do I do? What is this nigga supposed to do? What am I supposed to do, bro? You don't have the code here.
And the associated training labels and test labels. So let's first have a look at how this training samples look. So we want to print the shape of this one. So this is an
Okay. Canon. I need to copy all of this. No, don't do that. Amazon Q sucks. How do I copy all of this? Copy. Like, where is cloud code? No cloud code anymore? Okay. So however so let's look at the code. We have X train white test. So what is KNN anyway? Oh shit. KNN. Is he building it from scratch? Random forest. Okay, cool. Introduction to learning, nearest neighbor. I mean, where is KNN actually used? Is it used in anything? Yeah. Um, K means clustering. Is KNN even used? This is K mean clustering. Bro, linked list has never been used ever in life. When has linked list ever
A
been used?
NumPy ND array.
Give me a second. Does it work now? Let's cut this shit. Okay. Um, how do I visualize this? So what is the iris data set? How do I see this shit, bro? So iris data set load iris x iris data iris target. Whatever this is x. What the fuck is this? Genuinely, what the fuck is this? Like, I don't need a K implementation.
Of shape 120 by 4. So 120 is the number of samples and 4 is the number of features for each sample. So for example, let's print the first sample.
Okay, I need to
In this
refresh the
video,
K now.
I'm going to be building a linear
Linear regression is not so scary after all. Man, didn't who would have thought? KNN. What is scale-M algorithm in machine learning? I'm using in Python nearest neighbors simply gone.
regression.
Okay. Keep going.
Sample. So this is 4 features in it. So this is how our training samples look. And now let's have a look at our training labels. So this is a 1D row vector, also of size 120. So for each of our training samples, we have the label for it. So if we print this, then we see this will be a 1D vector with only one row. And now what we see here is we have labels 0, 1, and 2. So this is a 3-class problem. So let's also plot this. And
So what is going on here? So I just want to see plot dot show. Let's see how it looks. I can see what the train shape, test shape. Fair enough. So I'm gonna go. Should it be X? Yeah, X. Print. Why? I don't know. What the fuck is this?
now, for example, what I plot here is I only plot the first 2 features, so that we have.
What the fuck is this, bro? Genuinely, what the fuck is that? First, like, what is that? So C is equal to Y, C map. Now the keyword. Nigga, just give me map. C map is equal to. C map is equal to C map, comma. Edge colors is equal to.
have a 2D case. So this is how.
Okay, let's see. Let's take a look. Do you wanna? Okay. I'm a power user. I don't need Linux. Linux is for. So these are. What the fuck is the iris? I don't know. What is this? Plot scatter? What the fuck does this do? I think I learned pandas instead of NumPy for some reason. What does it do? Um, coordinates. Okay. What is build a recommendation system?
Our data looks. So we have 3 classes, red, green, and blue. And yeah, so this is how our data looks. And now we can continue by implementing this. So in our fit method, so in the KNN algorithm, this doesn't involve a training step. So what we do here is we simply want to store our training samples, and then we can use them later. So we can say, so let's store them. So let's say self, and then we call this x train equals x, and self y train equals y. So this is all for our fit method. And now for our predict method. So this will can get multiple samples here. So we can see this because we use a cap.
So what is this? What am I looking at? So we have a plotting going on. Good. X-axis.
K-nearest neighbors, one of the simplest algorithms used for classification and regression tasks. It includes a whole bunch of classes, but today we'll go with the K-neighbor classifier. Tasks. It includes a whole bunch of classes, but today we'll go with the K-neighbor classifier. Have you ever voted for someone? That's pretty much how classification is done using the K-neighbor classifier, by voting. It decides a class for new data points based on the majority vote of its nearest neighbors, and when we say nearest, we're talking mathematically closest. So how does this work in practice? Let's visualize it. Here's some data represented by red and blue dots. Suddenly, a black dot appears. It's a new, unseen data point. Our task is to classify this point. Does it belong to the red class or the blue class? The process starts by calculating the distance between the black dot and every point in our dataset. Once we have all the distances, we sort them in increasing order. Next, we select the k closest points, our nearest neighbors. By default, the value of k is 5. These 5 neighbors then vote to decide the class of the black dot. The class with the majority votes wins. In this case, the majority of the neighbors are red, so the black dot is classified as red. Simple, right? But how do we calculate those distances? The K-neighbor classifier uses a metric called the Minkowski distance, which is a flexible and generalized way to calculate distances. The formula looks like this. Here,
It's just like a normal. Wait, what? How is this? It's like a normal distance formula, right? How is this different from this? Distance. Wait, min count C. Whatever the fuck.
The parameter
Oh,
p controls the type of distance. Let me show you what that means. When p is set to 1, the Minkowski distance becomes the Manhattan distance. It measures the distance along the grid lines. When p is set to 2, the Minkowski distance becomes the Euclidean distance. This is the straight line distance, like using a ruler.
Oh.
Let's return to our data. This p is set to 2, the Minkowski distance becomes the Euclidean distance. When p
Manhattan.
becomes the Manhattan distance.
So Manhattan distance would be like a one-dimensional distance formula. Okay, that makes sense. Look at it. I'm gonna call. Alama. சாப்பிட்டமா வைக்கிறேன் பாய் சாப்பிட போறேன் பாய் So Manhattan distance will be like the one-dimensional array, and that makes sense. Makes a lot of sense. I think okay, I'm gonna eat. Bro, I need to do this. Fuck. How long have I? 9 minutes into a 4-hour video, 5-hour video. Shit. I'm doing this. This thing, I'm doing. Everything else, no, I'm not doing.